Hey everybody, welcome back. We're going to be talking about reservoirs in this video. So a reservoir of infection is the habitat that pathogen typically resides in. So reservoirs can be animals, like non-human animals like rodents or dogs, but they can also be humans, or they can be non-living things like soil or water. Um, if we know the reservoir, then we can potentially control diseases. If the reservoir is human only, we can often eradicate the disease. The example there is smallpox was eradicated, and it is a disease that can only affect humans. So human reservoirs can be symptomatic. So we can have a disease and show symptoms, or we can have a disease and not show symptoms. Remember, Mary Mallon, she had typhoid fever bacteria, Salmonella enterica, serotype typhi, and she did not get sick because she was an asymptomatic healthy carrier. Another example, 50% of women infected with gonorrhea are asymptomatic, but they can still transmit the disease to their partner. Non-human reservoirs that are animals can cause a lot of very, very dangerous diseases. A lot of times zoonotic diseases are much more traumatic in humans than they are in animals. Example would be rabies or plague, are both zoonotic diseases. Environmental reservoirs, these would be very hard to eliminate. And the reason for this is we can't get rid of dirt, we can't get rid of water, and these are environmental reservoirs. So in that case, you're not going to be able to get rid of the reservoir, so you have to stop the pathogen from spreading some other way. And one example of a way that we stop it, Clostridium tetani, which causes tetanus, we get tetanus shots, tetanus vaccines to protect us from that pathogen because it is in a reservoir that we can't control. So we know the reservoir of infection. Now we have to know, how does the pathogen leave their reservoir to get to the next host? So portals of exits and entry are typically the same. So if you have a pathogen that goes out through the gastrointestinal route, it probably came in through the GI route as well. So it might have entered through the mouth and it's exiting through the anus. Example, shigellosis. Shigellosis is oftentimes brought into the body through undercooked meat, and it exits the body through severe diarrhea. So that would be an example. Another example that your textbook talks about, Mycobacterium tuberculosis enters through the respiratory route via droplets, and it exits again through those droplets. So there are different ways that disease can be transmitted. You have vertical transmission. Vertical transmission occurs from mom to her offspring, or from a pregnant woman to her fetus. And then horizontal transfer is person-to-person contact via direct physical touch, or through ingestion of food or water, or through the air, or via a vector. So let's talk about some of these mechanisms. Direct contact occurs when two individuals actually directly contact each other. So it can be through playing with toys, it can be through a handshake, it can be through kissing. I mean, there's a lot of direct contact in your daily life with anybody. When you're giving when you're buying food and you hand money to the cashier, you can directly contact their fingers, and then you can actually transmit infections that way. And so here's some examples: kids playing together, direct contact, people kissing, another form of direct contact. Indirect contact is a little bit more complex. Indirect complex involves transmission of a pathogen via some object. So that object is called a fomite. A fomite is anything, any inanimate object that transmits a disease. So I can take a drink out of my glass, which you didn't actually see, but I did. I took a drink of my coffee. Now I could set my coffee down and my husband could come in. He doesn't like coffee, but just let's pretend he did. He could take a drink of the coffee from my glass, right? From my cup. If he did, if I had a disease, say I had a cold, now I've just transmitted those pathogens, the rhinovirus, to my husband via that cup. That cup would be the fomite. That's an example of indirect contact. Other examples, you can have food. If you share a candy bar, if you open a candy bar and you hand that candy bar to someone, if someone does that for you, their hands touch the candy bar and now you're going to eat it. Kleenexes, this is a favorite irritation of mine. When people take Kleenex and they blow their nose and they leave their dirty Kleenexes laying on their coffee table or on their side table. It doesn't take a lot to clean up after yourself. And if someone else has to pick up those Kleenexes, they're going to get those potential pathogens as fomites. But probably the most telling or the most common fomites are the ones that everyone touches. Not everybody is going to touch a candy bar or touch Kleenex. So people don't touch food, but everybody has to touch doorknobs. And so when you're walking into and out of your classes at school or going into and out of a store, you might have to open and shut the doors. So those door handles are fomites. And if you're not paying attention, you could touch a door handle after someone who's got a serious cold. I'm using cold because that's just so common. But it could be another disease too, like COVID-19. You never know, right? And then you get that on your hand and now you touch your face and now you're prone to getting that infection. So that's what a fomite is. And so how can we control direct or indirect contact? How can we control and protect ourselves? Washing your hands. If you're constantly washing your hands, keeping your hands clean, don't touch things that that could potentially cause or transmit a disease. But if you do, because everybody has to touch door handles, there's nothing you can do about that. Then, just wash your hands. That's the best mechanism. And actually for COVID, hand washing is one of the best mechanisms because COVID-19 or the coronavirus is an enveloped virus. And so when you wash your hands with soap and water, the soap breaks down that envelope and then the virus is inactivated. So other mechanisms of transfer would be droplet transmission. So think about someone coughing or sneezing and the respiratory droplets sit in the air, and then they're going to eventually float to the ground. But they are released, and if you walk through someone right next to someone who's coughing, then you're likely going to potentially inhale some of their droplet transmission. Another mechanism of transfer would be through food or water. So if you have contaminated water, then when you drink that water, you're going to potentially get sick. The best examples there would be Giardia lamblia is one of the common causes of diarrhea. Giardia is a protozoan that lives in water, and it can be transmitted if you are drinking water that is contaminated with it very easily. Another, of course, would be through food. Food, it could be because you're not cooking your food enough. It could be because you're not preparing food properly. And so these are two just different cartoons that I thought was funny. One salmonella burger coming right up. Great, but hold the E. coli this time. Ha ha ha. Or this looks like a good place to eat. Sam and Ella's Diner. Get it? Ha ha. Okay, I like jokes, so. So again, not preparing food properly or not cooking the food enough. And so here we're looking at a cutting board, a knife, and a set of scissors. So these are common items that we use to prepare food. But if you're not washing the food or washing the utensils properly, then these items could actually have or be covered with salmonella or staphylococcus or other potential pathogens. And what that means is when you cut up, say, your lettuce for your salad, you're now going to have these pathogens on the salad, and salad doesn't get cooked, so you're going to get sick. The final mechanism that we're going to talk about for transmitting is vectors, which we've talked about before. Vectors are living organisms that carry disease-causing microbes from one organism to another organism. So the example, the most common vectors are in the group Arthropoda. And so insects, ticks, mites are very common vectors of infection. And so all of these are cute little cartoons about these vectors, all right? Vectors can be external. So they can transmit disease externally, where you have a pathogen or an insect, like a fly, landing on a pile of poop and then moving to your potato salad. So that would be an external. The bacteria get onto your little legs, and then you move on to your potato salad or your burger, and you transmit that bacteria. You can also have internal transmission. That would be where the bacteria go inside, and I'm using bacteria, I should say the pathogen, because it's not always bacteria. The pathogen moves inside of the host and either just takes a ride and then actually enters the host, the actual host for the pathogen, and starts replicating. Or internally, they could actually have part of their life cycle. So a harborage would just be getting a ride. But in this case, it would be inside. Whereas externally, this is getting a ride outside. So sitting on their legs or on their wings. This one is inside. But if you're a biological if it's biological transmission, this means that the pathogen has part of its life cycle in vector. Okay. And so here we see a flea. Fleas use harborage to transmit disease. So when we think of this, we're looking at bacteria. Bacteria will build up in the flea's gullet. And when the bacteria fill up, if there's enough bacteria that are in that flea's gullet, then the flea can no longer swallow food. And so when it jumps onto a human host, like a human, when the flea takes a blood meal from the human, it ends up throwing up back into the human. And when it throws up, the bacteria go with it. And that actually leads us to this plague disease. So I'm going to erase this really quick so you can see this better. And so there's an example of plague caused by rat fleas. Okay. Or transmitted by rat fleas, not caused by rat fleas, caused by Yersinia pestis. And here's a biological vector. The mosquito Anopheles, the genus Anopheles, carries the protozoan Plasmodium, and the Plasmodium have their sexual life cycle inside of the mosquito. And I'm just going to write over here, harborage, okay? So the mosquito harbors the sexual stage. And then the human has the asexual stage of the protozoan Plasmodium. And so this is malaria that we're talking about, okay? And over here we're talking about plague. Okay. Oh, and again, that's actually the protozoan inside of our blood cells, human blood cells. They replicate via a process known as schizogony, where they replicate multiple times at once and then burst out of those blood cells, causing all kinds of problems, including hemolytic anemia. All right, I'm going to stop here and I will get into the next video talking about virulence in just a few minutes. Bye.